right, welcome to the coffee break. And today I'm going to talk about front-end engineering. Sometimes I talk about engineering as a team sport, and if I look at, for instance, football, the first down is very important. It could be strategic to win the game. So what I want to talk to you about today is the first down in engineering. Let's take a look how that works. Okay, so I said about the first down, is important, strategic in a football game, but also if you think about it, important in engineering. And with the first down, I mean the front-end engineering part of the project. If you look at the pie chart here, you see that the money hours spent in the engineering office is relatively small to the total capex investment. It's maybe between 9–13%, in my example, but it can vary, of course. But you see, even smaller part is the feed, the front-end engineering and design, or front-loading, as some people call it. But it is a very, very important part, because that 2% has basically a major impact on the rest of the project, including what's happening in the engineering office and of course what's happening in the field to construct it. Because if you see here on this particular graph, the impact is very large in the beginning, but of course goes very, very much down when you go to detailed design and construction. When you construct a plant, or even when you're far in the detailed design, what can you change? You may have already bought equipment, you may have made design decisions. So this front-end engineering is absolutely a very, very crucial part of the cycle, and it determines how you can execute your project, how you will do on the budget, how you will do on making this project go well, both in operation and maintenance as well. You make early on some critical decisions in this part. Now, of course, what we support is we're not doing the simulation. We have partners to do the process simulation in the graph, or any, there are market leaders out there like the Aspens and like Invensys and the Honeywell that do this very, very well. So the thing that we need to do is we need to take all their information, all their runs, and move it into an environment where we can do process engineering. With process engineering, I mean, we finally come up with all these cases, and we have to find out what the governing case or design case, or whatever you want to call it, the case is that you actually, base your design on. That is something that you need to do in this part. And then you have some external solutions that will help you actually to size equipment and size lines as well. Now, after you're done with that, and you have your design case that you can base your equipment on, and your lines on, and so on, then you move it into the layout. Now, a very important part, of course, of this front-end engineering is how you lay out your plans. There are many variables that decide how you lay out your plan. It could be the location, and it could be, how much space you have available, and so on. So what happens is that you make different scenarios, because a little bit longer pipe rack or a little bit shorter pipe rack has a major impact on the cost. And there are, of course, the programs out there, solutions out there, some in-house developed, some commercial solutions that can take this information from these design cases and process design and process flow diagrams and the layout, and come up, with the cost. And of course, cost is important, and to determine, if you get the green light from the owner to go ahead with this investment, yes or no. So this is a very important part, and you make major decisions in this particular phase. So the challenges are, when you do this front-end engineering, it's a big topic, so I go over some major highlights, but of course it is fast track. Often, when I also was in engineering, you get this notice that you have to do a front-end engineering study, but the owner wants to know very, very quickly, what these costs are gonna be, and if he wants to go ahead or not, because you have a time to market that is very important to the owner to be, it's a very competitive environment. So, normally it goes very, very fast. Then you have to come up with all these different scenarios. Cost, we talked about cost. Cost, of course, is important, but also the technology. What type of technology are you selecting for that particular process. I mean, the process technology. So that is also something. Some owners want a certain technology, they have their own technology, or they have done plans that are with similar plans that they reuse that same technology for that. So you have to take that in consideration as well. And then, believe it or not, you know, people sometimes don't think about it, but the plant is using also a lot of energy, and just like your car, and of course energy is expensive, and we want to be running this plant as efficient as possible. So the layout and the design, and in those early phases, you also determine, you know, how this plant is going to operate and how much energy are you going to use, how much steam you need to produce, how much electricity for pumping and all that stuff are you going to use for producing the product that you're going to produce. And of course location is important. You know, it makes a difference if you build it in the North Pole or in the middle of the desert. And there are more things. Now of course also very important is safety. Nobody wants any accidents, so early on, you know, you can also determine, and you have to be some initial, of course not detailed, but some initial safety studies. HAZOP is maybe a big word here, but you definitely have to look at the safety aspect in these early phases as well, because if you don't think about it now, later you will have maybe an issue when you do a more detailed design and you have to go and backtrack. Nobody wants to do that. Now, the last point I want to make is, you know, building on experience. Obviously, what have worked well in the past hopefully will work in the future well as well. So you want to capitalize on these past experience. So we want sometimes to reuse design. So sometimes, you know, when we do these studies and we got all these cases and we got all these, you know, equipment sizing and line sizing and maybe already decided on some technology, we want to reuse that particular design for the next project. So we must be able in this particular feed project and scenario, and that will also help with the fast tracking, to reuse something we've done before, maybe tweak it a little bit based on maybe different location for this plant than the previous one, but use that technology that we already selected and has worked well in the previous plant that we built, and capitalize on that for this. So design reuse is also an important part. And once we have this package done and you get the green light for the project, which of course everybody hopes, you know, it's good for all of us, then of course this can be funneled through the detailed design and then finished you know, with the details for building the plan. So I guess with that, you know, I want to leave it. Of course, we can do maybe another coffee break or so to do more details on a certain aspect of this feed. It's a big part of it, and like I said, it is very, very important, because remember, in this 2%, you know, as an example, the small part of the pie, you make the maximum impact on how this project is actually executed. So thank you, and hopefully we'll see you in the next coffee break.